Welcome back to Made Easy Academia. So you are still under the number system, just like what we have mentioned before. You're still under the number system, and I said under this number system we have series of them. We have the natural numbers, we have integers, we have rational numbers as well. We have irrational numbers as well. We also have we have what we call complex numbers, and we have real numbers. So I've explained what they call the natural number before. So natural number, it simply means the counting of numbers. When we have a number like that, when we have the numbers, the counting of numbers is what we call the natural number. So now let's talk about the next one. We have what we call integers. So when we have integers, integer is like the expansion of a natural number. That is, it comprises of a number with positive and negative. You know, if you call under the natural number, we said that one is only when we have positive, like a 1, 2, 3, 4, 5, like that. And mind you, in this case, either we have a natural numbers or integer or whatsoever. In some cases, I mentioned like prime integers, and I told you that we also have another case like when we have non-even numbers, when we have odd numbers, when we have prime number, like that. And I've already explained that, but to make it more interesting, I will still explain them so that you can be able to know the difference of each of these numbers. We talk about what we call even number. We said even numbers are those numbers that can be divided by 2 without remainder. Whenever you have what we call even numbers, are those numbers that can be divided by 2 without remainder, like 2, 4, 6, 8, 10, and 12, and so on. So the other one we have what we call odd numbers. Odd numbers are those numbers, just like the opposite of even numbers. That is all those numbers that cannot be divided by 2 without remainder. Like this example, and we have odd number like 1. You know, if I have 1, can 2 divide 1 without remainder? Yes, sure. So we have like 3, like 5, 7, 9, 11, and 13, and so on. That's what we call the odd numbers. So another one we have what we call the prime numbers as well. So when we talk about the prime numbers, are those numbers, prime numbers are those numbers that can only be divided by 1 and itself. So what does that mean? The only difference between the odd numbers and prime number is that under the odd numbers, is all the other number can go there without remainder, except 2. But under the prime number, only 1 and itself. Only 1 and itself. Like what? Like 2. You can see if I pick 2 now, the other number can divide 2 without remainder. So only 1 and 2 itself. So like 3, like 5, like 7, like 11, 13, and so on, like that. So in this area, we can tally them with a number system, meaning we can have the categories of natural numbers, we can have the categories of integers or rational or irrational. It depends on the problem we are tackling. Now, so when we're talking about integers is like the continuations or the positive and negative of a natural number. Like under that one, we can have, let's just see, just like positive and negative of natural numbers, extension of a natural number, like we can have like -4, -3. Let me define it in the simplest way so that you can get the concept. It's like extensions of help us to fill the marker. So just like extension of is any number, just like what we have here, integer is any number, or is a number, let's use that way, is a number in forms of -4, -3, -2, -1 is 0, 1, 2, 3, 4, and so on, like that. Meaning, if you look at natural number, if you check example that we discussed under the natural number, we say it only comprises of a positive number, like counting of number like 1, 2, 3, 4, like that. But under the integer, it comprises of the negative as well, the positive, just like the extension of natural number. You can even define it in that way, like extension of natural number. Recall I told you that natural number is denoted by capital N. So when we extend that natural numbers, we call it integer. Like it can be minus 20, it can be minus 4, it can be minus 30, whatsoever. So when we have a positive and the negative of a natural number, we call it an integer. Recall, I told you some properties under the natural number, like we talk about commutative, we talk about associative, even law of trichotomy. So here too, we also have something like that. So we can have some properties of integers. What are the properties of integers? Properties of integers. The first one, just like the way we have on the other one, we have commutative. Commutative. Meaning, if I have two natural numbers together, if I have two integers, if I add them, like for example, let's say I have x and y to be an element of integers. So in this case, the symbol that we normally denoted for integers is z. You know, the other one we are using capital N, right? So in this case, whenever you see z, z is for integers. So now, let's say we have x and y to be an element of integers, meaning two numbers, any numbers. So far it's an integers, that if I have x plus y, then it has to be equal to y plus x to be commutative. So what does that mean? Let's pick any number for x. Let's say let x equal to 5. You know, 5 is an integer, right? So let's say we have y also to be 2. Now, if I had this x plus y, will definitely equal to y plus x. So let's check. So my x that we have here is 5, isn't it? That is a 5 plus, so the one we have is 2, is 5 plus 2 equal to y again, that is a 2 plus 5. So here 5 plus 2 we have 7 equal to 7. You can see, even if you pick a negative, let's assume that you pick a negative, the law will still hold. That's the beauty of this integer. You know, now I pick positive. Let's take a look at if I pick a negative, for example. Let's say we have, let's take x to be minus 5 and let's take y to be let's say minus 2. So we are trying to test that is it true that integers satisfy a condition of commutative. Now the law I brought is that x plus y must be equal to y plus x. So let's check that if I use the negative, I add these two numbers together, can it equal to when I have them? Now that means I can have minus 5 plus minus 2 will give us our y is a minus 2 plus our x is a minus 5. If you missed our previous video, please, I treated when we have two signs, when the sign follow each other. I treated that one, that in mathematics, whenever we have minus times plus, we say that one is going to change to, if I have minus times plus, or let's take from here, we say this one is positive, and when we have plus times minus, we say that one is minus. When we have minus times plus, we say that one is going to be positive. Or when we have minus times plus, we say that one is going to be negative. And I also told you, when a sign follow each other, like if I have minus, minus, follow each other. I told you when we have minus, minus, follow each other, it's going to be positive. So now, and if we have a plus, minus, or plus, or minus, plus that follow each other, of course, it's going to be minus. So now, if you look at this case now, what I have here is a plus, and what I have here is minus. So now, if plus and minus follow each other, of course, we are going to have what? Yes, exactly. We are going to have minus. That means that we have minus 5 minus 2. Then equal to this one too as well, minus 2. So plus and minus, when it follow each other, we said from this law that is going to be minus 5. It's just like the way we are multiplying the two signs. That when we have minus times plus, or when we have plus times minus, so also similar to this. If I have two signs, just like you have a minus, and you also have another minus that follow each other, of course, that one is going to change to positive. You don't need to perplex about that one. So either they have a multiplication sign between them, even if you have 3 signs or 4 signs that follow one another, you are going to treat them the same way. So now, minus 5 minus 2. So here, do not say minus times minus. Do you know the reason why? The reason is, here, there is no sign of multiplication here. So we have to be careful with this. You know, there is no sign of multiplication. It's like you are adding something, just like the way we normally had. That's exactly what we have here now. For example, let's say I own Made Easy Academia 10,000, and I want to pay them, let's say 3,000. You know, automatically the amount I own there is more than the amount is more than the amount I want to pay back. So that's exactly what we have here. Let's say I have 2 people, I own the person minus 5. At the same time, see another one 2. So no, if I pay, if I no, that means there's nothing to pay here. I want to combine my debt together. So meaning, if I have minus 5 minus 2, it's like you are combining two signs together. So minus 5 minus 2, of course, and we have minus 7. So here too, minus 2 minus 5, of course, and we have minus 7. That means truly integers are commutative. So you can pick any number, even you can pick a number as positive and negative. If you text it again, of course, if the number you picked is an integer, the law will truly hold. Now, another one we have, apart from commutative, we have associative. That's another one we have. We have associative, related commutative. We explained that. So if you check our material, you see how we give some examples. More than that, then the second one we talk about is associative. If they ask you that is integers satisfy the condition of associative, the answer is yes. You know, let's say I have, let's say we pick 3 integers. Let's say let x, y, z to be, okay, since I have z to be a symbol for integers, let's use another one. Let's say I pick p, q, r to be an element of integer. I've told you this one is just like element, meaning this p, q, r, they are integers randomly. So that means if I have p plus q plus r, we equal to p plus q plus r. If this condition satisfied, we can say that one is highly what? Highly associative. What does that mean? Let's pick 3 numbers. You can pick any number of your choice. You can even try, apart from the one I will use, so that you check that is it truly that this law satisfies the condition of associative. You can pick any number of your choice. Let's say I pick, let's p to be 5, and let q to be 4, and let r to be 2. You know, you can see all these numbers are integers, right? So now, just like the way we have it on that natural number, you know, if you check the natural numbers, if you missed the previous video, check that one. I treat how we can make use of some laws under the natural number. So now I pick 5, 4, and 2. We know 5, 4, and 2, they are truly an integer. So we want to test that is integers truly associative. So let's check. If I put it there, that is a bracket. I want to first tell you one we have in the bracket first. So my p is 5. I can have 5 plus, so my q is 4. We have 4 plus our r is 2 equal to, here 2, what I have is 5, that is 5 plus our q is 4 and our r is 2. So now 5 plus 4, meaning we have this one to be 9 plus 2 equal to 5 plus 4 plus 2. Of course, we are going to have 6. Now 9 plus 2, what are we going to have for 9 plus 2? Yeah, that one is 11. Then 5 plus 3 also is going to be 11. You can see that the two are equal. So please check for negative also. You see, truly will satisfy the condition of associative. Now, apart from the associative, we still have another one, trichotomy. You know, I told you what they call trichotomy for the natural number, just like the way we have trichotomy, the law of trichotomy for natural number, we also have it for integers as well. Like law of trichotomy, meaning if I have 2 integers, one of the conditions must satisfy. If I have 3 integers, that is the result we surely hold like this. Let's say we have x and y to be an element of integers. So one of these law will hold. You see that x greater than y, or x is equal to y, or y greater than x. So that means if you have 2 integers, one of these 3 will hold. Surely, yes, of course, it will hold. Let's say, for example, let's say we have, let's say we take x to be 5, and I take my y to be 9. Let's say, for example. So, or you know, if I have x greater than y is nothing but y less than x, right? So now let's take a look at this. X is equal to 5 and y is equal to 9. Definitely, this means that x is less than 9. X is less than 9 here because x is now up to 9, right? So that is 5 is truly less than 9. Or I can write that as 9 greater than 5. But if, assuming I pick x to be 5 and I pick y to be 5, of course, that means the second law will hold, which means x here is equal to what? Is equal to 5. For the law of trichotomy, one of these two must hold. It's either the first number greater than the second number, or less than the second number, or they are what? Or they are equal. So we also have, let me add this one to you so that you can get it more interesting. We have what we call prime integers. You know, from the word prime. Don't forget, when we have prime, let me explain that one too as well. We have what we call prime integers. Before we move to and then that one too is also distributive. You know, I've taught you, if you check the first order natural number, is similar to that, either distributive toward the left and right. I've discussed that one too earlier. So now we have what we call prime integers. So prime integers can be positive or can be negative since it is a prime. Integers, you know, when we have integers are those numbers that's just like extension of natural number. So when they now say prime integers, now that means they've indicated that it's a prime. The number we are, you know, I've already explained what they call prime. We say prime are those numbers that cannot be divided by any other number except one and itself. So if they now say prime integers, meaning the integer we are going to pick must be an integer, and must be a prime. You know, we can have even integers, right? And we can have prime integer as well. That means any number I want to pick out must be what? Must be a prime, and that number must be an integer. Okay, let me firstly explain. You know, the integers we have, as mentioned earlier, we said integers can be maybe, let's say, -4, -3, -2, -1 is 0, 1. You know, if you look at this number, we have even there is odd, at the same time there is prime, isn't it? So, but it indicates that prime integers, meaning the integers I must pick out must be a prime. Can you give me an example of that? Yeah, so that means if I want to pick out the prime integers now, the prime integers here, I can pick prime integers. That means we can have, even if it's negative, we can have -3. Why do we pick -3? -3, you know, is an integer. That's the first condition. 3 is a prime because it can only be divided by 1 and itself. You can even pick 2 or -2 or -5 or -7 or 10, or 11 rather, or -11, or I can pick plus or minus 17, meaning either plus 17 or minus 17. So all those numbers that are integers, but they are prime, that they can only divide by 1 and themselves, we call them prime integers. So this one to also satisfy the condition of distributive, either by the left or by the right. You know, under the distributive, we talk about check for the natural numbers. For the distributive, let's say I have 3 numbers, like let's say x and y, z, or let's say let's pick a, b, c to be an element of integers. If I have a plus b of c, this one would definitely be equal to ac plus bc. With 3 other one under natural numbers. You can pick any number of your choice to check if this one will truly satisfy the condition of integers.